This is Anthony with Embrace Tutoring and Educational Services, and in this video we're going to be targeting the SAT Math Practice Test 1 Section 3 and specifically questions 11 through 20. We're going to get started going over question 11. It says, in the equations above, B and C represent the price per pound in dollars. So B and C represent the price per pound in dollars of beef and chicken respectively. Now, respectively means that B is obviously referring to beef and C is referring to chicken based upon the order that they have. It says X weeks after July 1st during last summer. What was the price per pound of beef when it was equal to the price per pound of chicken? So this is my biggest indication here of what I want to start with. So first off, I'm going to quickly clear this. That way I have some space to write neatly. That way you guys can see it. Now, the big sense is, what is the price per pound of beef when it was equal to the price per pound of chicken? I have two equations up here, so it's not exactly a system of linear equations, but more or less, I'm going to be able to set these equations equal to each other. And by doing that, I can then isolate and solve for x. Now, when I isolate and solve for x, I can then take that x, and I can essentially plug it back into either of these equations to figure out what the total price per pound of beef is, or what is the total price per pound of chicken. This question is asking me, what is the price per pound of beef? So I first want to begin by setting these equations equal to each other. So I see B equals C. So I'm going to try and write small that way I have enough room. So 2.35 plus 0.25x equals, so this is my equation for B, equals the 1.75 plus the 0.40x. Now, I want to be able to solve this through and isolate x. To make things a little bit easier, I'm actually going to first take 1.75. I'm going to subtract from both sides, so minus 1.75. Now I'm also, in order to carry this through in terms of the 0.25, I'm going to subtract the 0.25 here. And by subtracting the minus 0.25, right, x, what I'm going to end up getting, when I solve all this through, right, 2.35 minus 1.75 is going to give me 0.60 with two decimal places equals 0.15x. Now I want to be able to solve for x first, so that way eventually I can plug that back into one of the overall equations. So I'm going to take this 0.15. Right, divide that out. Here I have 0.15. This will end up giving my value for x. And try not to overthink this. I know this is the non-calculator section, but since you have two decimal places here, two decimal places here, this is simply just 60 divided by 15. So you know that x equals 4. Now, I like that, and quickly glance, you're noticing that these aren't, right? So x equals 4, but that's not a possible answer choice because, like I mentioned, you're going to eventually have to take and solve for price per pound of beef. So B equals 2.5 plus 0.25x. I want to substitute x in here for 4. So I'm going to have B equals 2.35 plus 0.25. I'll darken that decimal there. So 0.25x. And here I'm going to have B equals 2.35 plus my 0.25 times 4 is going to give me 1. So this is going to be 1 plus 2.35. B is going to be 3.35 altogether, which D is my best answer. Problem 12 states a line within the xy plane passes through the origin and has a slope of 1/7. Which of the following points lies on that line? Now, one quick word of advice when you're taking the SAT is when you think of slope, do your best to actually think of it as just rise over run. Rather than thinking of this as, generally many of you will think of it that the y2 minus y1 over the x2 minus x1. You often won't have time to do the entire equation in terms of figuring out slope. And often you'll have to figure out a quick graph to help illustrate and then just use the rise over the run. In this case, your slope is 1, right, over 7. So I'm going to go up one space and move over to the right or left, depending if I reverse this order, right, 7 spaces. It says a line in the xy plane passes through the origin. That definitely helps me because it tells me where, at least somewhere on this line, I can go through and where a point of reference is. and has a slope of 1/7. Which of the following points lies on the line? So if I were to graph a quick graph here, and to make things even easier, I'm going to take a quick peek here. Notice all of these are positive. And because all these are positive, I really want to focus within this quadrant, right? Within the positive quadrant. And I'm going to do my best to make these lines easier for you. So 1, 2, 3, 4, 5, 6, 7. Here I'm going to have 1, 2, 3, 4, 5, 6, 7. Now, I purposely went to the 7th because I may have to rise, right, 7 places. So if I do this, then I know that I'm going to be passing through the origin, right? So there's my 0, 0 mark. And I know I'm going to go up 1 and over 7. So notice this is my x, this is my y, right? So I'm going to go up 1 and I'm going to go over 7. 1, 2, 3, 4, 5, 6, 7. Right? So one of my spaces will go here. Now, just to reverse that order quickly, I'm actually going to do, let's see, 1, 2, 3, 4, 5, 6, 7. Come down here. I'm going to do 1, 2, 3, 4, 5, 6, 7. Just to get a general idea. I would go down 1, and then I would go 1, 2, 3, 4, 5, 6, 7. All right, here's my other point. Now my line is going to look somewhere like this, just when you're drawing that out. So this particular point here, if I go over 7 and up 1, right, there's my x is 7 and my y is 1. And we're going up. So every time you see this particular expression, right, 7 comma 1 in parentheses, think of x comma y, just to help you out. And I noticed that this possible answer choice isn't any of these, right? Matter of fact, many of these answer choices are kind of all over the place. So here's my 0 to the 7th up there. This is essentially where A would lie, but that's not correct at all. And then B would be over 1 up 7 as well. That also would, so B would be around here, also not correct. So A and B are totally off. C would be over 7 up 7, so C is all completely over in this area, which is also completely off. Now, why does D work? Well, if I were to continue this function out and go up 1, right, and over 7, you'll come to understand that by adding another 7 to this in terms of the x, I end up getting 14. And by adding another 1 here in terms of the y, I get 2. Now, you're more than welcome to continue to do this on, but D is going to be your best possible answer when graphing. Problem 13 says, if x is greater than 3, which of the following, let me get my pen here, right? If x is greater than 3, which of the following is equivalent to this? Now, these particular problems can be somewhat tricky, but the real wording, what you want to look for is which of the following is equivalent to. Notice that I have a variable here within my question. So I have variables within my question, and I have variables within my answer choice. So whenever you see this wording, which of the following is equivalent to, right? Which of the following is equivalent, variables within my question, variables within my answer choices, you can theoretically solve this through. However, the fastest way to do this by a method of what we call choosing numbers. So the real idea behind choosing numbers is that you want to be able to plug something into this expression and then solve using the possible answer choices. And in this case, it says if x is greater than 3. Well, the best number to choose then, if x is greater than 3, is 4. Right? So we're going to want to choose 4 in order to solve this expression that you see here. Because, right, why make it harder on yourself? Just choose the next greatest number that solves this, this inequality. So if x is greater than 3, choose 4. If I have 1 over 1 and 4 plus 2, and then plus, I'm going to do 1 over, I'm going to plug 4 back into x here, which is going to be 4 plus 3. This, remember, this is a large fraction for 1 over 1 plus 6, right? So 1 over 1 plus 6. And this is then going to be plus, right, 1 over, right, 4 plus 3 quickly is 7. So here I have 1 over 1/6 plus 1/7. Now, I want to find the common denominator then between 1/6 plus 1/7. So if I'm going to do, right, I'm going to have 1 over here, and then this 1/6 is going to become, right, 7 over 42. And my 1/7 is going to become 6 over 42. right? If I had to multiply here, right, 42 is the common denominator, multiply this by 1 by 7, 742. 42 is the common denominator, multiply this 6, or multiply this 1 by 6 in order to get 6 over 42. This then gives me 1 over, let's say, 13 over 42. Now remember, whenever you have a fraction of a fraction, you're actually going to want to take this and multiply by the reciprocal, as if it was doing, right, 42 over 13 for both of these. This will end up canceling, and you'll see that altogether, your answer should be 42 over 13. Now, to make your life a little bit easier as well, you're going to look for something that's actually within the fraction form. So 42 over 13, right? C is not going to be the case, and D also not going to be the case, because you'll see that that is also within the fraction form. Make your life also a little bit easier. You'll see that 42 is a greater number than 13. So in terms of saving time, you're going to want to try and find the number that's greatest on the top, right? In this case, the numerator, versus the denominator. Right, here I have x squared, so if x is larger, then b is definitely going to be my best possible answer. But for those of you that want to try and plug this in, you're welcome to do the x squared. Let's actually clear this real fast so that way we can check. We know that b is the answer, but we're gonna do our best to prove it. So knowing that, saying that x was equal to 4, we can say that x squared plus 5x plus 6 all over my 2x plus 5. Remember, all of this should theoretically equal my 42 over 13. Well, I'll first try this out, and I'll put the x down here in the bottom. So that way I have 2 times 4 plus 5. Well, that's going to give me 13, so I like that. I'm already working this out. Now, I should have moved on, but right, I'm still checking this. That way we can kind of solve the work together. And I have 4, right, squared plus 5 times 4 plus 6. So here I have 20, here I have 16, here I have 6. Yes, that does add up all together to 42. B still continues to be my best answer. Terrific. For problem 14, I see that it says if x minus y equals 12, what is the value of 8 to the power of x, 2 to the power of y? Your biggest hint within this problem is that you see an x and a y here in terms of the actual exponents. You also see that the x's and y's are prevalent here, so you're most likely going to have to find a way to take this information and plug it into here for this information. So then the million-dollar question is, well, why the 8 and why the 2? Often for exponent problems on the SAT, you'll have to be aware that you want to think about 8 in terms of 2 to the third power, especially when you're dealing with exponent rules. If let's say I have 8 to the power of x, right, over 2 to the power of y. Well, my 8 to the power of x actually ends up becoming 2 to the third power, but this also still goes to the power of x. Now, I'm still over my 2 to the power of y. The idea is that by getting the same base here, that I can simply just remove these and then kind of conjoin them. So if I have the 2 to the third power of x, then this becomes 2 to the 3x, right? If I were to distribute this in, I would multiply, right, my exponents together, and now I have 2 to the power of y. Well, according to your exponent rules, what happens when you have the same base root and you have a 3x, right, and a y? Well, what would you do when you need to flip the side, right, together in order to get everything within the same side of the fraction? Well, this would become 2 to the 3x minus y. But notice what we just did, right? Notice what we have now. We have the actual expression that they provide you in the very beginning. So 3x minus y equals 12. So if we were to substitute that in, that becomes 2 to the power of 12, which is a possible answer choice for A. Nicely done. So 15 says if ax plus 2 times bx plus 7 equals 15x squared plus cx plus 14. So I'm noticing that this c here as well is another variable, plus 14 for all values of x. A plus b equals 8. That's a big hint because I know a plus b is going to be 8. What are 2 possible values of c? Okay. Many of you will probably try and FOIL this out, which will take a lot of time. But think about where these numbers actually come from. That will save you the most amount of time because then we're going to have to rationalize and start to eliminate some of these possible answer choices. So if I have 15x squared plus cx plus 14, I'm thinking about where does this 14 come from and where's that 15 come from? And I'm knowing that essentially a times b is really what is giving me 15. So if I know that a times b equals 15, they give you another hint, which is a plus b is actually going to be equal to 8. So if I have a times b equals 15, if I have a plus b equals 8, I'm going to set this up in terms of basics. And I'm thinking, okay, well, a times b equals 15, a plus b equals 8. Well, if I have 5 and I have 3. Now, also know that the x to x squared is represented here. So this is going to be 5x plus 3x. And it really doesn't make a difference what side you put them on because you're just trying to figure out the relative value that it could be. Now, I'm also trying to think, okay, well, what two values could essentially give me 14? So in that case, I would probably think, okay, well, I'm going to have 7 over here, and I'm going to have 2 over here. I sort of jumped a step of why I'm putting that positive down, but I see that this is positive and this is positive. Now, because of the fact that the middle term is also going to be positive, and yet I don't know the sides of if it's going to be the 5x in this side or the 5x in that side, I do know that both of these are going to be positive though, right? If this is positive and this is positive, then I know that both of these, when they're completely FOILed out, are going to be positive together. So if I were to take, just playing around, right, 5x times 3x, this is going to give me my 15x squared. So I'm good. That works. Now, what about if I do my 5x times 7? Well, that's going to give me an estimated 35x, right? And then if I take my 2 times my 3x, well, that's going to give me a 6x, right? So altogether here, I have a 41x. And now 2 times 7 gives me 14. So here I have a possible equation that works, and I have a possible value that does work. Now let's skim our answer choices. Yep, okay. So D does work in terms of 41 filling for C. And we're good to go. Okay, problem 16, and it says if t is greater than 0, here, t is greater than 0, and t squared minus 4 equals 0, what is the value of t? Okay, now t squared minus 4 seems pretty simplistic, right? Or if I were just to do t squared equals positive 4 here, well, I know that t is going to equal 2. But theoretically, because this is squared, this could be positive or negative 2. Now, your piece of information here in terms of t is greater than 0 means that t can actually only be positive 2. So positive 2 is your answer, and it can't be negative. 16 says, a summer camp counselor wants to find length x. So I'm going to quickly skim this. Okay, there's length x in feet across the represented in the sketch above. The lengths represented by AB, EB, BD, and CD on the sketch were determined to be 1,800 feet, 1,400 feet, 700 feet, and 800 feet respectively. So very quickly, this, remember, respectively is referring to the same sequential order. So AB is going to be 1,800, EB is going to be 1,400, BD is going to be 700, and CD is going to be 800. So I'm going to fill that in now. That way we can kind of have everything that we need. Okay, so AB is going to be 1,800, and I know BD is going to be 700. I also know that EB is going to be 1,400, and I know that CD is going to be 800. Okay, now it says, respectively, segments AC and DE intersect at B, therefore making this an intersection and making these angles here a vertice. So it looks as though the other angles are also congruent. Right, so I'm going to make this, right, this vertice here congruent. It says AEB and CDB. Okay, so AEB, yes, AEB. So this is, say, the first angle. This is also the first angle, which is congruent. And now these vertices are going to be congruent. Now, quickly remember that in order to solve for the value of x, what you really need to know out of this problem is the law of similar triangles. And if 2 out of the 3 within the triangles are equal, then that last angle is also going to be equal. So I'll label this by the third angle. So first, second, third. And then here we are. This is going to be my third angle as well. So angle A is going to be congruent to angle C is what I'm trying to get at. Also notice really where the angles are pointing, right, in terms of the opposite side. This angle B, which is congruent to this other angle, is going to be pointing here. This triangle is going to be pointing to the 800, whereas this angle within this triangle is going to be pointing x feet. Why do I need to know that? Well, in terms of a similar proportion, what I'm going to want to do is I'm going to want to set up an x over 800, and so I'm taking the second angle here to the 800, and then I'm taking my second angle here over to the x feet, right? So this is another triangle. I'm going to set up a proportion so that way I have one triangle on the top and I have another triangle on the bottom. So here's my b going to x and my b going to 800 for the sides. Then I'm going to have another triangle where it's going to be 1400 for here. So I'm going to have my third, right, going to 1400. And it's important to use this third angle to 1400 and this third angle going to 700. And so now I'm going to have my 700 on the bottom. Quickly notice that this triangle, BDC, right, has these sides where it's 800 and 700, right? These sides, 800 and 700 on the bottom of this proportion or this fraction. Whereas the other triangle, AEB, has the top side or the numerator. So x equals, right, the 1400 over 700. So make sure that you attempt to label them correctly. The quick way of doing this, rather than just cross multiplying, which you very well could do, you can do 800 times 1400, right, divided by 700 in order to solve for x. But quickly think to yourself, well, how does 700 go to 1400? And in order to do that, you're going to have to multiply by 2. So 700 going to 1400 is multiplying by 2. So I know that x is going to equal 1600, and that is my answer. It appears as though I have a system of linear equations problem. It says, according to the equations above, what is the value of x? Now, as we previously discussed in the other video, that whenever it asks you to solve for x, you want to do your best to immediately eliminate y. If I want to eliminate y, then I'll have x plus y equals negative 9, and then I'm also going to have x plus 2y equals negative 25. If I want to eliminate y, I'm going to take this top equation here, and I'm going to multiply it by 2. And the purpose of me doing that is so that way I can then have 2x plus 2y equals negative 18 for my top equation. I then, on the bottom, have x plus 2y equals negative 25. Well, look at this. If I take this entire bottom equation and I subtract it out, the 2y minus the 2y will cancel. That's the whole point of me doing it in this method. So if I have 2x minus x, this then becomes x. And then if I have negative 18 minus negative 25, I'll write it over here really quickly. So negative 18 minus negative 25, right? This is going to be negative of negative, becomes positive of positive, becomes 7, right? So overall, x is going to equal 7, and I don't even need to solve for y. Okay, problem 19 states, in a right triangle, one angle measures x, where sine of x equals 4 over 5. What is the cosine of 90 minus x? So it seems as though I'm trying to solve, and I know that 90 minus x is going to be 2 out of the 3 angles that are present within my triangle. So if I were to write my right triangle over here, what it appears that it looks like right now, I always have my 90 degrees or my right triangle symbol. Now the side opposite of that is going to be my hypotenuse, and we'll discuss that very quickly. And then let's just label this down here as x. So that's my x. This elongated side is always going to be my hypotenuse. And it says that I have sine of x equals 4 over 5. Now, quickly, in order to do this particular type of problem, you need to know what is called SOHCAHTOA. And SOHCAHTOA is standing for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So if I have sine, I know that I need to know what is the opposite over the hypotenuse. And if I have the angle x here, if this is referring to what is the sine of angle x, then I know that this is going to be my opposite, right? Opposite of that specific angle. Then this which being my hypotenuse, is going to be 5, right? So sine of 4 over 5, opposite over hypotenuse for sine. I also know that this is the 90-degree angle and that this is the angle x. I don't know what this last angle is. Let's just call this C because it's referring to cosine anyway. So angle C we don't know yet. And what we do know is that in every triangle, you have 180 degrees. So you know that 180 is going to equal angle C plus angle X plus your 90 degrees, right? Now I'm getting the 90 degrees from the right triangle. So I have 180 equals C, right, plus X plus 90. If I subtracted out the X and the 90, then I would end up getting 180 minus 90 degrees minus X equals C. This, right, is kind of really what I'm looking for because I want to see how this is related to the rest of the triangle. And my hint is that the fact that they're subtracting this X as well as a 90 degrees. That's my hint of why I'm trying to figure out this other angle. So here I have 90 minus X equals C. Well, look at that. That means that this here is the actual angle that I'm looking for in terms of C. So if I have cosine of C, right, cosine of angle C, this means that I'm going to have my adjacent over my hypotenuse, right? Adjacent over hypotenuse being so toa, right? So cosine is going to be adjacent over hypotenuse, which means that this side over here would be my opposite, referring to the cosine, but this side over here would be my adjacent, referring to the cosine, as well as this would continue to stay my hypotenuse. So this is going to be cosine of 4 over 5, which is going to be my full answer. It says if a equals 5 radical 2 and 2a equals radical 2x, what is the value of x? Well, it seems pretty basic, where if 2a equals radical 2x, I really want to try and isolate x and get it by itself. But they give you what a is. So you can plug a into here, knowing that this is going to be 5 radical 2 equals the radical 2x. Now, so I'm going to take this 2, I'm going to distribute it through. So this gives me 10 radical 2 equals radical 2x. Okay, so mathematically, how do we end up solving and removing this radical? Well, in order to do that, I want to take each side and square it. So I'm going to have 10 radical 2 squared, right? Everything together within the parenthesis, and then radical 2x squared, everything together within the parenthesis. As you can see, many of you will probably be able to make this distinction, which the radical 2x squared is going to become 2x. But many of you may sort of get tripped up on is this 10. Because if you have 10 here, this 2 goes to both. It goes to the 10 as well as down to the radical 2. So this becomes 10 squared times 2 altogether. So 10 squared times 2, and the 2 I'm getting from the radical 2 squared. Altogether, I'm going to make this 100 times 2 equals 2x. I would then just simply divide by 2, right? Divide by 2, cross that out. What I'll end up getting is that 100 equals x. Remember that if you have any questions at all, you're more than welcome to visit www.embracetutoring.com. Stay tuned for the next video.